So let's look at this question number 2. Now a box contains 2 blue and 3 pink. Another box contains 4 blue and 5 pink. One ball is drawn at random from one of the two boxes. One ball is drawn at random, okay, and it is found to be pink. So it is found to be pink. Find the probability that it was drawn from the first box. Let's see how to solve this. Now you have to find that, let's say if I define events over here first, that there are two boxes, let's say B1 and B2. These are boxes B1 and B2. So I'll be naming it B1 will be box B1 is selected, and B2 will be box B2 is selected. B1 event is box B1 is selected, B2 is box B2 is selected, box B2 is selected. Then what else I want is, so he's talking about only pink, found to be pink. So I'll define A as box found to be the ball is pink. Okay, so what he's asking in the question is find a probability that it was drawn from the first box. It was drawn from the first box, and it is second question is from the second box. So if I define it this way, found to be pink means this event is already done. This event is already done. So I can say P of A will come in the denominator and it will B1 upon A. This is your first question from box 1. And second question is P of B2, that is box 2, okay, upon A. Probability that A has already occurred. Since A has already occurred, it is from the second box is what you want. Okay. Now we'll be using the concept over here. P of B1 upon A is, what we do is we take A as a sample space. A as will be the sample space, and out of which we'll be taking intersection of B1 intersection A. That is B1 intersection A. So when I say B1 intersection A, I can solve this. That is P of B1 upon A is equal to P of B1 into P of A upon B1, A by B1, and in the denominator you want is the total probability. Now total probability, how will I get P of A? Now what exactly is P of A? What the sum says is there are two bags, let's say B1 and B2. So if there are two bags B1 and B2 and A is an event associated with both, A is an event is associated with both because the ball can be pink from the first bag and also the ball can be pink, we can get it from the second bag. So if I split this event into two parts, this part and this part, then I will have two events over here. First is bag B1 is selected and I get A, that is half of A, and bag B2 is selected and I still can get A. So and these two can be written this way: P of B1 into P of A by B1 plus the second part P of B2 into P of A by B2. Now P of A actually I have found by using the denominator over here. The denominator over here is found by using total probability theorem. So this part is actually found by using total probability theorem, and this entire thing over here is nothing but Bayes theorem. ये जो मैंने पूरा लिखा है यही है Bayes theorem का पार्ट. तो ये Bayes theorem अगर मुझे लिखना है तो मुझे ये इंफॉर्मेशन कहाँ से आया मैं तुमको बता दिया अभी कि ये जो डिनोमिनेटर में है वो Bayes theorem नहीं है, ये मुझे टोटल, ये डिनोमिनेटर का पार्ट मेरे टोटल प्रोबेबिलिटी थ्योरम से आया है. ओके, जो कि मैंने पहले भी एक्सप्लेन किया है. सो व्हाट आई एम गेटिंग इज P ऑफ B1 upon A is equal to, now I should have the values probability of B1. Now probability of B1, that is दो bags है तो it will be half, and probability of B2 will also be half. It is that simple. So I want P of B1, that is half आ जाएगा into. Now I want this probability of B1 A upon B1, A upon B1, that is probability of getting A from the first bag. Now in the first bag, if you see, there are there are three pink. So if there are three pink over here and there are five pink over here, so can I say probability of getting it from the first bag is, clearly it can be seen that it is 3 out of 5. That is 3 by 5. And probability of A upon B2 is, that is getting a ball, that is pink ball from the second, is 5 out of 9. 5 out of 9. Now I'll substitute the values over here. P of A by B1 is 3 by 5 divided by, now you are getting this as 1 by 2 into 1 by 2 into, and I'll substitute those values again, which are 3 by 5 plus this is 5 by 9. Now when I calculate this, what will I get? I'll get what will get this 3 by, okay, half will get cancelled, half will get cancelled, and I have to cross multiply. Then 3 by 5 upon 9 3s are 27 plus 25, 27 plus 25 is 52, and 9 5s are 45, which is 5 1s are 5 9s are, okay, 9 3s are 27 upon 52. Okay, this is your answer. So this is a probability of getting from the first box a pink ball which you already got, that is from the first box. Now so the second question will go same way. The second question will exactly go the same way. P of B2 upon A can be calculated this way. Now you can just replace the numerator. A shortcut method over here can be just write the inverse reciprocal of this. Okay, that is P of B2 into P of A by B2 and divided by the total probability, which is again you already found out, P of B1 into P of A by B1 plus P of B2 into P of A by B2. Now if I calculate this, what will I get? So P of B2 upon A is equal to P of B2, probability of getting ball 2 is half into probability of A by B2. Probability of A by B2 is 5 by 9 divided by 1 by 2 into 3 by 5 plus 1 by 2 into 5 by 9. Now if I calculate it further, I'll get 5 by 9 divided by half will go away, that is 9 3s are 27. Again I'll get the same 52 by 45, and here the calculation is 5 5s are 20, 9 5s are and 5 5s are 25 upon 52 is your answer that you get. So let's look at this sum. It says there is a working women's hostel in a town where 75% are from neighboring town. So 75% are from neighboring town. Let's say if I consider woman 1 from the neighboring town, okay, event that is from the women are from neighboring town, neighboring town, And W2, if I consider women are from the same town, because he is talking about two things over here, two events. One is woman from the neighboring town and another woman from the same town. Now, if there is a working women's hostel in a town where 75% are from neighboring town, so 75%, if I say probability of women from neighboring town are 75%, okay, 75%, so I can say this is 75 by 100, which is 3 by 4. And if this is 75%, then of course from the same town it has to be 25%, because these two events cannot exist at the same time. These are mutually exclusive and exhaustive also. So 25 by 100, which 25 ones are 25 fours are. So you get probability of women from the same town is 1 by 4. Now what are you saying? 48% of women who hail from the same town are graduates, and 83% of the women who have come from the neighboring town are also graduates. Now 48% women, okay, who hail from the same town, who are already from the same town, that means this event has already occurred, that they are from the same town, that is W2 has occurred. And I can say the probability that 48% of the women who hail from the same town, okay, same town means W2. And there is one more thing over here, 48% are graduates. So let me take one more event over here that says women are graduates. Okay. So if I say, if I take G as women are graduates, okay, women are graduates. So probability that the woman is graduate from the, given that she is from the same town, is given to you as 48%, which is again 48 upon 100. Then 83% of the women have come from the neighboring town. Who have come from the neighboring town means they have already, this condition are already done. That is W1 is already done. And again, they are also graduates. So probability that they are graduates and from the neighboring town is 83%, which is 83 upon 100. 83 upon 100. Find the probability that a woman selected at random is a graduate from the same town. Now, what exactly you have to find? Let's see. Find the probability that a woman selected at random is a graduate. So, she is already a graduate, but from the same town. From the same town means I have to calculate, same town means W2. So, this is what they asked you. So, here P of G will become my sample space, and this will be P of G intersection W2. So probability of G intersection W2. Now, if I look at it, probability of W2 into probability of G by W2, okay, divided by P of G can be calculated by, it's a, so if I try to draw this diagram to get the total probability, now what he is saying, some are from neighboring town, some are from same town, and the graduates they are talking about, okay, graduates. So N is nothing but neighboring town, which is W1. S is nothing but same town, which is W2. So total will be, the woman is W1 and she is a graduate, and the woman is taken from this W2 and she is a graduate. So W1, P of W1 into P of G by, so P of G upon W1 plus P of W2 into P of G upon W2. This is your total probability. That is P of W2. Probability of W2 is, I can put everything in terms of 100 if you want. That is 25 by 100 into G by W2 is 48 by 100. Then P of W1 is 75 by 100 into P of G of W1 is 83 by 100 plus P of W2 is 25 by 100 into G by W2 is 48 by 100. So if you solve this, 100 will go away. You are remaining with 25, 25, 25. Here there is 3. So 48 upon 3, 3s are 9, 3 8s are 24 plus 48. This makes out to be, this is 249 plus 48. Finally, you will get 16 upon 99 when you calculate this. Students, this part over here that I have written, P of W2 by G, this part here is by Bayes theorem. This part is by Bayes theorem. So we have even A2 are likely events, mutually exclusive events over here. P of A upon E1, P of E1 upon A. So these are the values that you want to find. P of E1 when A has already occurred. Okay, now if you look at this part, then we can easily say A is a sample space. And this part in the numerator will be intersection of E1 as well as A. So this will be again probability of E1 into probability of A by E1 plus, sorry, not plus, divided by, this will be a total probability. Now, if you look at the question, what it says, E1 and E2 are equally likely and mutual exclusive. This is E1 and this is E2. Okay, and there is some A over here. So I can say A will have two parts, one part from E1 and one part from E2. So it will go like P of E1 intersection A and E2 intersection A, which is P of E1 into P of A by E1 plus P of E2 into P of A by E2. So this will be P of E1. Probability of E1 is equally likely means the probability is half. So we'll half into A by E1. A by E1 is 0.2 divided by half into A by E1 is 0.2 plus half into probability of A by E2 is 0.3. So it is 0.2 upon 0.5. If you calculate, you will get it as 2 by 5. So this is your answer. So let's look at a new question. That is question number 5. Jar 1 contains, now jar 1, if I say J1 as 5 white and 7 black. Jar 2 contains, I can say this is J2, which contains 3 white and 12 black. A fair coin is flipped. Now there is a coin over here which is flipped. So when you flip a coin, either you get head or a tail. So the probabilities of this is half half. Probability of getting a head or a tail is both half and half. So if it is flipped, a fair coin is flipped, if it is head, a ball is drawn from jar 1. So if it is flipped and it is head, it will go from jar 1. And if it is a tail, it will go from jar 2. Suppose that this experiment is done, a white ball was drawn. Now what he is saying, a white ball was drawn, W. So let me just start with, if I say J1 and J2. J1 is, let's say, ball is drawn from jar 1. And J2, if I say ball is drawn from jar 2. Okay, ball is drawn from jar 2. So a fair coin is tossed and you get the probabilities. No? So there are two events again over here. I can say one event. Okay, but these two cannot happen simultaneously. At a time only one can happen. So two events are there, but at a time only one can happen. That is, these are mutually exclusive and exhaustive. So probability of getting a head is also 1 by 2, and probability of getting a tail is also 1 by 2. Okay, probability of getting head is also 1 by 2, and probability of getting a tail is also 1 by 2. Now what he says is, what is the probability that, suppose that experiment is done and a white ball is drawn. So white ball is already drawn. That means you have P of, okay, let me define another event, that a white ball is drawn. W, let's say we are taking white ball is drawn. So W event is white ball is drawn. So probability of white ball is, means white ball is already drawn. So I can take this as a sample space. Okay. So I can take it below W. What is the probability that this was in fact taken from second jar? Second jar means I can say J2. Okay. So that is from J2, I can say. Okay. This is how it is. So over here, again, probability of selecting jar 1 and jar 2 is again half and half, because it depends on indirectly head and tail. So indirectly has given me P of J1 and P of J2 only. Okay, indirectly. So to find P of J by W2, I will take the sample space P of W, and I'll take the intersection of J2 intersection W. Now, if I look at the denominator, that will be solved by using total probability theorem. Now, what exactly is total probability theorem? That I'll be using. Okay. So I have jar 1 and jar 2. Okay. And out of that, I have taken another event that the ball drawn is white. So J1, and from jar 1 we are getting white ball, and from jar 2 we are getting white ball, and these two are total probabilities. There can be only two possibilities, that is J1 intersection W and J2 intersection. So J1 intersection W can be split like P of J1 into P of W by J1 plus P of J2 into P of W by J2, and in the numerator it is P of J2 into P of W by J2, that is jar 2. Now P of J2 and J1 you already know, that is it is half. Okay. Now what is W by J2? W by J2, if I look at it, from jar 2, if I want white, it is obvious that it will be from jar 2. I have how many whites over there? You can see 3 out of 15. P of W by J2 is 3 out of total 15. So this is 3 out of 15. This will be again half and half. This is half into, and this is half into, plus. So W by J1. W by J1 means this part. W by J1 is, I can say, getting White from J1, that is 5 out of 12. 5 out of 12. That is 5 out of 12. And this will be 3 out of 15. So when we calculate this, we get 1 by 2 into 3 by 15. So half will go away. You will be left with 3 by 15 upon 5 by 12 plus 3 by 15. So if we divide this, you'll get the, or else you can directly cross multiply this. Okay. So this is, I'll reduce it further, 1 by 5 upon 5 by 12 plus 1 by 5. So this is 1 by 5 upon 25 plus 1 is 25 plus 12 is 37 upon 60. So 5 ones are 5 12s are, that is 12 upon 37 is the answer.